All right, so in section 3.6, last section of chapter 3, we do more money problems, and instead of doing loans, we're going to do savings. And savings problems are a little more complicated, specifically because signs of the dollar amount sometimes get to be important, and the PY and the CY aren't always going to be the same. And it's kind of oversimplifying things to make the PY and the CY always the same number, but I continued with that just to not make it look any more complicated, and keeping them the same is not such a big deal. And it's, I mean, if this was a finance class, like a Finance 300 kind of level class, we'd probably not keep them exactly the same, but it's good enough to keep them the same. The numbers that you get by making them different aren't really substantially different. So anyways, because when people are savings, they often take money directly out of their paychecks and put it into the retirement savings, the PY and the CY can be different. And I get paid every 2 weeks. Mostly that means I get paid twice a month. But every year there's 2 different months that I get 2 paychecks. This upcoming March I'm going to get 3 paychecks, should I say. And for every 2 weeks, the PY/CY is going to be 26. I get paid 26 times per year because basically there's 52 weeks in a year, and if you divide by 2 for getting paid every 2 weeks, you get 26 paychecks. So in savings problems, the PY and CY might wind up being 26. That's if somebody's saving for retirement and they're getting paid every 2 weeks. On the other hand, my brother gets paid twice a month, on the 1st and the 15th. And if you get paid twice a month, you get 2 paychecks every month for the 12 months in a year, and you get 24 paychecks. You don't get those 2 months where you get 3 paychecks, but then your paycheck's slightly bigger because of it. These are the big differences between the PY and the CY in this chapter and the PY and the CY in the last chapter. My parents are on Social Security, and they only get paid once a month. And if you're only getting paid once a month, well, then the PY and the CY are going to be 12. But there's other PYs and CYs that might come up in this section, but the big ones are the every 2 weeks compared to twice a month. So we're going to use the same screen to solve savings problems as we did for loan problems, and we're going to may have to think of the letters a little bit differently depending on the type of question that's being asked. The N's not so different. The N is the total number of payments. In the loan problems, it was usually the total number of months times the total number of years. Like if I had a 5-year car loan with monthly payments, I'd multiply 5 times 12 and get 60 for my N. It's kind of going to be the same here. If I'm saving for retirement and I get paid every 2 weeks and I'm saving up for 10 years, I'm going to go 10 years times 26 deposits per year, and I'll get the 260 for the N. So the N is usually the number of years times the number of payments per year. That's just the same as in loan problems. The I is the interest rate. Again, that's not different either. It's the ugly PV that gets to be a little bit tricky. The PV is going to be the amount of money that's already saved up, and unfortunately the sign of it's going to be important. And whether you're in the process of saving up for retirement, or if you're already retired and pulling money out of that account, the sign of the PV is going to make a difference. When you're young and saving up for retirement, the PV goes in as a negative amount. And then when you're done, like my parents saving money, and not that they ever saved any money, they never had money to save, but nevertheless, when you're pulling money, when you're spending out of your retirement funds, the PV turns positive. So the PV is negative. For most of us, it's going to be negative when we're figuring out our future savings. But once you get into the world of being retired, the PV is going to turn to a positive value when we want to figure out how long your retirement savings might last. The PMT is generally the amount that, the recurring payment. Like I get, say you get $100 taken out of every paycheck, put into your retirement account. That's going to be the PMT. We'll normally let the PMT be a negative number. I can't think of a case in this section where the PMT isn't going to be negative, but if it comes up, I'll explain it. On the test, I won't have any problems where the PV is positive, so the PMTs could always be negative. In the car problems, the FV, the future value, was always 0 because I always wanted to have my car paid off in the future. I don't generally want my FV to be 0. My FV is the future value. That's generally the amount of money I want to have saved up when I retire, and when I'm planning for retirement. And that's usually entered as a positive value if I have to enter that value. And then the PY and the CY I talked about already. And that ugly begin end, we're just going to leave it on end. Remember, for car payments, if you put it on begin, that would assume you're getting your first payment is due the day that you buy the car, not a month later. Similarly, if you put it on begin, then it would kind of assume that the first time you pull money out when you retire is the day that you retire, and not like 2 weeks afterwards. Again, that's kind of a weak explanation, but it's adequate. For our class, we'll always leave the bottom on end. All right, so let's just do a simple savings example. So again, we have to figure out, for most of our problems, the PV, we got to figure out the N, the I, the PV, the PMT, the future value, the PY and CY, which I'm going to make the same, and I'm going to leave the calculator on end. As I read through this example, the first number I see is $100, and it's an amount that's deposited into a retirement account every 2 weeks. This first sentence, in a sneaky way, has a couple of the values that we need to solve the problem, even though I haven't gotten down to what the question is. This $100, because it's a recurring amount, a repeated deposit, that's a PMT. Generally, PMTs go in, should say FV here, not FY. It should go in as a negative. The next thing, every 2 weeks, this person is getting paid every 2 weeks. If you're getting paid every 2 weeks, there's a 2 weeks each year that you get, 2 months each year that you get 3 paychecks. The PY and the CY are 26. So going through the first sentence, I know the value for the PMT, the value for the PY and the CY. Now I'll move on to the second sentence. The investment is expected to earn 5% compounded every 2 weeks. So that I is going to be 5%. The every 2 weeks is just kind of repeat again. And then it says compute the balance after 25 years. Well, this is going to help me get the N. The N isn't the number of years, it's the number of deposits. And so I'm going to take the number of years times the number of deposits per year to get the N. So I did 25 times 26 and got 650 for the N. So I've run through all the numbers and all the words that implied numbers in the problem, but I'm still having some blanks. And the blanks are PV and FV. The PV is, in a savings problem, is any money that you already have saved up. The FV is the value that your account grows to in the future. We're trying to find what our account goes to in the future. So for the FV, I'm going to hit the green alpha button and solve for it. So hit green alpha and then enter. But I need to get a value in for the PV before I do that. In the car problems, the FVs were like always assumed to be 0. The PV in savings problem is any money that we already have saved up. Because we don't have any money saved up, I'm going to put a 0 there. And now I'm going to have my calculator help me solve for the FV. So I'm going to go back to the app screen. So I'm going to go Apps, enter on Finance, enter on TVM Solver. If I want to, I could physically type 25 times 26 right in the N, and it's going to give me the 650 that I figured out on my calculator earlier. I'm going to type 5 for the I, 0 for the PV, negative 100 for the payment, because payments generally go in as a negative because they're money that I'm spending. The FV I'm going to skip over because that's what I'm going to have my calculator solve for. And I've typed 26 for the PY, and it'll change the CY to 26. I'm leaving my calculator an end for every problem in this chapter. Now I'm going to scroll up to the FV, hit the green alpha button followed by enter, and I'm going to round to 2 decimals. And it's going to say just putting $100 every paycheck away for the next 25 years. If I round to 2 decimal places, you'll have $129,280.10 saved up. Alright, so now we're going to do some homework problems, and just kind of like I've been doing, I'm going to start doing the first problem with you, and then I'll let you do a problem. So question 1, as I read through this, I know when I go to do part 1A, I'm going to use the TVM solver, which means I need an N, an I, PV, a PMT, an FV, a PY, a CY, and I'm going to leave my calculator on end. So for part A, the first number I see, $150, is deposited into retirement account every 2 weeks. That by default gives me 2 of the values for the problem. The every 2 weeks is 26 for the PY and the CY. And the $150, because you're making more than one $150 deposit, that's a PMT. The $150 is going to go in as the payment, and it's going to be negative. Second sentence, the investment expects to earn 5% interest compounded every 2 weeks. The only new number in that sentence gives me the I. And then for part A, compute the balance in the account after 10 years. That means I'm trying to solve for FV, because I'm trying to find the value in the future. That also by default means I need to put something in for PV. PV is the amount of money I would have had saved up to start. It doesn't talk about any money in my savings account, so I'm going to put a 0 there. And in for the N, I'm going to plug in 10 times 26 for the 10 years and 26 payments per year. That's going to be 260. I'm staring at a mistake. I wrote I equal to I, although that's not wrong. It's not going to help me. I should have put I equal to 5. Now when I do this computation, I should be fine. So in for the N, I'm going to plug 10 times 26. In for the I have 5, PV 0, payment negative 150. I have the PY and the CY and the end in. I'm going to arrow up to the FV. I'm going to hit my green alpha button followed by enter and round to 2 decimals. I'm going to round that to 53 cents. For part A of number 1, I'm going to write $50,538.53 for my answer. When I go to part B, it's going to be really surprising. If I save for 3 times the length of time, it's going to be more than 3 times the money. So for part B, it just is supposed to show you that if you start saving when you're young, the amount of money you get is pretty substantially more. So I'm going to answer using the same paragraph of data, meaning everything's the same in the screen except for the N. So the difference between part A and part B is that the N has changed. In part B, the N is going to be 30 times 26. I think that's 780. Still the same 5% interest rate. I'm still not having any starting up money. I'm still saving $150 per month. I'm still going to hit the green alpha and enter to figure out the PV. Still making deposits every 2 weeks, so the PY and the CY are 26, and we're always leaving our calculator on end. So I'm simply going to just arrow up to the N, type 30 times 26 because everything else that I had to write in was there, and I'm going to arrow down to the FV, hit my green alpha and enter, and my answer for part B, so I get like 5 times the money, even more than 5 times the money. It's $271,068.57 will be saved up by putting $150 a week away, every 2 weeks away, at 5% interest for 30 years. All right, why don't you give 3 a go? I'll do 4. In order to do 4, so you can pause the video and do 3, when the answer that I have written down for 3, just in case you want to check yourself, is $541,088.52. That's assuming my answer is right. I'm kind of hoping that's the case. If you can't do number 3, watch me do number 4. If you can do number 3, don't watch me do number 4 and fast forward a little bit. So as I read through the problem number 4, in the first sentence I see $300 is deposited in a retirement account every, should just say twice a month. And that 300 is a PMT. It's going to go in as a negative amount because it's money I'm spending. Twice a month is 24 for the PY and the CY. So for my PY and my CY, I'm going to put 24. Done with my first sentence, move on to the second sentence. The investment's going to earn 9.5% interest compounded twice a month. That gives me an I of 9.5. And then compute the balance in the account after 40 years. The N is going to be the number of years, 40, times 24. What's that, 16? 16. I think that's 960. Let me just go to my calculator to make sure that's the case. Yeah. Again here, I'm going to green alpha and solve this for the future value because I want to know how much money I have in the future. And in for the PV, I'm going to put 0 because that's any money you would have initially saved up, which I don't have any. So I'm going to type in 40 times 24 for the N, 9.5 for the I, 0 for the PV, negative 300 for the PMT, 24 for the PY and the CY. I'll go up to the FV, hit the green alpha button followed by enter. And for my problem, if I did this right, I come up with $3,286,772.21. The big deal here, 40 years is a great amount of time. That made kind of the values get really big, but this 9.5% was almost equally impactful in terms of the amount that the $3 million that it grew to in the future. I used to, in the 90s, assume 11% for the growth rate because that's what the stock market did on average. But we had a lot of lean years, and so now when I project, what I'm going to have in the future, I do like 7% for my estimation for my growth rate because that's more conservative and it's kind of realistic. All right, new kind of problem. The only difference between this kind of problem and the last kind of problem is we're going to have $2 amounts. Let me just walk through this. So first sentence, $100 is deposited into a retirement account every 2 weeks. That gives me a couple of bits of information. All the problems in this savings section, we're going to go from the screen. I don't think we're going to live in those sum of interest balance screens ever for these problems. So first sentence, $100 is deposited every 2 weeks. It's a more than one deposit, so that's a PMT. I should put it in as a negative because it's money that's being spent. The every 2 weeks part of this gives me the PY and the CY is 26. Second sentence, the account already has a balance of $5,000. That's the present value. And when we're saving up money, the present value when you're saving up money and you already have money saved goes in as a negative. So if I was retired and pulling money out, that money would go in as a present value and be positive. When you're saving money, the present value needs to go in as negative. This $5,000 is going to be the present value of that account, and it needs to go in as a negative because we're still saving up money, because I'm trying to find the balance in the future. The investment is expected to earn 5% interest, so that's the I. Compounded every 2 weeks. Compute the balance after 25 years. Again, the N is the number of years times the number of deposits per year. So the N is the 25 times the 26, which I snuck on here for myself and wrote 650 down. And I'm going to solve for the future value, leaving the bottom on end. So as I do this, in for my N, I can type 25 times 26, 5 for the I, negative 5,000 for the PV, negative 100 for the PMT, change the PY and the CY, arrow up to the FV, hit my green alpha button followed by enter, and that's going to give me, if I round to 2 decimals, $146,710, and I'm going to round that to 88 cents. So the only difference between this problem, probably makes it more realistic for a lot of people, is we have a small balance in our retirement account, and we're still adding to it. When that's the case, the amount that you're depositing every paycheck goes in negative in the PMT. The amount that you currently have saved up goes into the PV as a negative as well. All right, into a homework question. I'll work through number 5 with you. It's going to be just the same kind of question with different numbers. So if I work through number 5, I know that I need to get an N, an I, PV, a PMT, an FV, a PY, a CY. I almost don't even need to write N because it's going to be end every time. First sentence, $100 is deposited into a retirement account every 2 weeks. That's more than one deposit. That's a PMT, and PMTs we generally put in as negatives. The every 2 weeks tells me the PY and the CY are 26. Twice a month would make it 24, but every 2 weeks is when you get the 3 paychecks twice a year in a month. The account already has a balance of $10,000. That's a PV. I'm still finding the value in the future, so it's a savings problem and not a retirement, not while you're retired. That $10,000 goes in as a PV and it's negative. The investment's going to earn 8% interest. That's an I. I'm going to solve for the future value. In for the N, I put the number of years 30 times the number of payments per year, which is 26. I think that comes out to 780. Let me enter these and see where I go here. So on my calculator on the main screen now, for N, I'm going to go 30 times 26, 8 for the I, negative 10,000 for the PV, negative 100 for the PMT, 26 for the PY and the CY. Now my green alpha and followed by enter. And I come up with $434,261.92. I'll let you do number 7. I think I'm going to skip number 8. Let me write down the number 7 for you. It's exactly the same kind of problem. The big trick here is it says $800 is deposited in the retirement account every month, not every 2 weeks, not twice a month. In this problem, it up. The PMT, that's still easy. That's going to be a negative 800. In that first sentence there where it says the amounts deposited every month, there's 12 months in a year. The PY and the CY are going to be 12. And as you work through the problem and try to figure out what the N is going to be the number of years times the number of deposits per year. Your N's going to be 15 times 12, which I think is 180. I'll let you figure out the rest, and I'll write down an answer on my key that's sitting in front of me that I hope is correct. I got 268,000 $814.57 for my answer to that. Okay, another example. Seems like a realistic example. Joe wants to have $1 million saved up when he retires in 25 years. Can I do anything with that first sentence? Well, this $1 million is an amount of money I want to have saved up in the future, and that's a future value. And generally, so FV is the amount of money I want to have saved up in the future. Normally that's entered as a positive number. So immediately when I'm reading about Joe, even though I haven't got all the way through the problem, I know one of the values that I'm going to need. For Joe, his future value is what he wants to have saved up in the future. So if the future value is going to be a positive $1 million, when he retires in 25 years, the N is going to be the 25 years times something, but I don't know what it's going to be times yet. But I know the N is always the number of years times the number of deposits per year. Joe doesn't have any money saved up so far. That tells me that the PV is going to be 0, because the PV is any money you already have saved up. He plans to have money put into a retirement account twice a month, and twice a month is going to help me fill in a lot. For twice a month, the PY and the CY are 24, and it's going to help me figure out the rest of the N, because the N is the number of years times the PY or the CY, and apparently 25 times 24 is 600. So Joe wants to have a future value of $1 million saved up in 25 years. That's part of the computation for the N. Joe doesn't have any money saved up, so the PV is 0. He plans to put money in a retirement account twice a month, so the PY and the CY are 24. The other number that you multiply to get the N by is at 24. He hopes the investment earns 8% interest. That's what the I is going to be. How much does he need to deposit to reach his goal? This is what Joe is going to solve for. He's going to solve for how much he needs to get taken out of his paycheck to get there. So let me try to figure this out. So I'll go right to the top of my screen, and for the N, I'm going to type 25 times 24, or just the number 600, 8 for the interest rate, 0 for the PV. I'm going to ignore the PMT. I'm going to type 1 million for the future value and 24 for the PY and the CY. I'm going to arrow up to the PMT, hit the green alpha button followed by enter, and this means Joe would have to deposit $523, and I'm going to round that to 74 cents. I'm going to ignore the sign even though my calculator puts the sign in. I generally don't put that sign in my answer. So Joe, to retire in 25 years, he's got to save $1,000 a month, because 2 paychecks each of a $500 withdrawal, it's $1,000 a month to get to $1 million for 25 years. All right, let's work through number 9 together. I think I have an answer written down for number 9, but I don't see it anymore. So now I'm rolling the dice when I do this. If I try to find my, here's the answer for number 9. I think my answer to number 9 is $313.31. So I'll work through 9 with you and we'll kind of see where it goes. I'll skip over 10. So for number 9, I'm going to gear up. I'm going to set up for my N, my I, my PV, my PMT, my FV, my PY, my CY, and I leave it at end. So Jerry wants to have $1,250,000 saved up in 30 years. The $1,250,000 is going to be the future value. Future value is going as positive. The 30 years helps me find the N, but I'm going to need to multiply that by something before I have the full N. Jerry does not have any money saved up so far, so the PV is going to be 0. He plans to put money into a retirement account every 2 weeks, and every 2 weeks the PY and the CY are 26. So immediately when I saw that every 2 weeks, I put a 26 in for the PY, a 26 for the CY, and The N is the number of years, 30 times the number of the deposits per year, which is the PY and CY. The N is going to be 30 times 26, which is 780. He hopes his investment to earn 9% compounded every 2 weeks, so the I is 9%. How much does he need to deposit to reach his goal? I'm going to solve for the PMT and hopefully get to the right answer. So I put everything on here that I thought needed to be on here. I have 30 times 26 or 780 for the N, 9 for the I, 0 for the PV. I skip over the PMT temporarily, put the 1,250,000 in for the FV, 26 for the PY and the CY, and then alpha and enter. And I see $313.31 for the rounding, so that's perfect. Should give 11 a go. And for number 11, just don't really want to have these answers at my fingertips. For number 11, I don't know what I did with the answer. For number 11, I came up with $644.12. So I'll talk through 11 with you a little bit, just the hard part. And is there a hard part? The $250,000 that Jerry wants to have saved up is going to be a future value. The 10 is part of the N. The N is going to be 10 times some number. Jerry doesn't have any money saved up, so the PV is 0. He plans to put money into a retirement account twice a month. The twice a month, the PY and the CY are 24. That tells me for the N, you have to multiply 10 times 24 and get 240. He hopes to have, for an interest rate of 9%, which is the I, and then you're going to solve for the payment. So it's exactly the same that we've kind of what we've been doing. All right. Next kind, and maybe the last kind of problem. I'm not sure if I want to go all the way through this section. Let me get through these next bank of problems and see kind of if I feel like this is a good stopping point to keep things kind of consistent and not get confusing. So, example, Joe wants to have $1 million saved up when he retires in 25 years. Joe already has $25,000 saved up. Oh, there's so many numbers. Let me get them in my list of numbers here. First number, Joe wants to have $1 million saved up in 25 years. That's going to be the future value. He already has $25,000 saved up. That's a PV. That's a current balance. And Joe is still trying to saving money to get to that goal. This value, because I'm saving up money, is going to be a negative amount. That $25,000, that's this current value, that's the present value of his account. It's going to go in as a negative $25,000 because he's still saving up money. He plans to retire in 25 years. That's part of the N, but not all the N. I have to multiply to figure out what the N is. He plans to have money put into retirement account twice a month. And twice a month, the PY and the CY are 24. So I'm going to put a PY and a CY for 24 for the twice a month. And for the N, I'm going to multiply the 25 by 24, and apparently I'm going to get 600 for the N. So million for the future value, 25 for part of the N, you have to multiply it by this 24 for the PY and the CY. $25,000 is a PV, it needs to go in as a negative. He hopes his investment earns 8% interest, so the I is 8%. How much does he need to deposit? Well, the only thing that's blank, I need to solve for the payment. So let me get these in here. In for the N, I'm putting 25 times 24. In for the interest rate, 8. In for the PV, negative 25,000. In for the future value, 1 million. And in for the PY and the CY, 24. Arrow up to the PMT, hit my green alpha followed by enter. This says Joe has to deposit $427.31 to get to that $1 million in 25 years. That's about $850 a month. All right, 13 through 16. Let's work on these then. I'll work on 13 with you. Our goal for number 13 is to get an answer of $164.82. So let's see if I could actually get there. So for Jerry, let me set up his table here. So Jerry wants to have $1,250,000 saved up in 30 years. That's part of the N and the future value. The future value is going to be $1,250,000. The N, part of the N is going to be 30. I'm going to need to multiply by something. Jerry already has $40,000 saved up. That's a PV, and because he's still saving up money, that goes in as a negative. He plans to have money put into a retirement account every 2 weeks. Every 2 weeks is the PY and the CY 26. Twice a month is the 24. So not only am I going to put the PY and the CY, I'm going to multiply the 30 by 26. He hopes his investment earns 9% interest. How much does he need to deposit? That's what I'm going to solve for. Let's see if we can work through this then. So in for the N, I type 30 times 26. Turns out to be 780. 9 for the I, negative 40,000, I forgot a 0 there, for the PV. Skip over the payment, do 1,250,000 for the future value. Change the PY and the CY to 26. Arrow up to the payment, hit my green alpha button followed by enter, and I see $164, and that rounds to 82 cents, so I feel good about that. All right, once you give 15 a go, and for 15 I came up with $612.49, and I'll talk through it with you a little bit. Again, the amount of money Jerry wants to have saved up in the future has to be the future value. The 10 years is part of the N. The N's going to be 10 times something. The $5,000 already saved up needs to go in as a negative, and it needs to be the PV. He plans to have money put into his retirement account twice a month, so that gives me a PY and a CY equal to 24. Tells me to multiply the 10 years by the 24. He hopes for investment to earn 9% interest, so the I is going to be 9%. And then how much does he need to deposit to reach his goal? That's a monster deposit, because when you have a short amount of time, like 10 years, so if you're kind of older when you start saving up for retirement, it really gets to be really tough to get to the amount that you want to get to. The rest of the problems in the section have to do with when people are retired and they're spending beyond their retirement. Let me skip these because I think it's going to be safe just to keep them separate, because this is when it starts to confuse the situation. This is when the signs and the PVs and starts to change, and maybe we should just not do those. If you're interested in planning on pulling money out while you're retired, or you want to help your parents figure out how much money they can pull out of their retirement account if they're old enough to be retired, I can work through these with you. But for our purposes, let's just skip the end of the section. You can read through it if you care to, but we're going to skip the rest of the section, which is problem 17 through 21. Just actually maybe even 17 through 23, I guess, just so that it keeps things kind of realistic and it doesn't kind of bury you with some tricks in terms of the signs. These are important problems, but maybe not important when you're not thinking about retirement. So we'll or not thinking about spending your money during retirement. So we'll just stop there for this section and call it done. And again, if you want to learn how to do the rest of the problems, I'd be happy to sit with you if my explanations are not good enough.